This is a solution to number 6A on your final exam, which asked for the first four non-zero terms and the general term for the Taylor series for the function f about x equals to 2. Now, normally when you have to find your Taylor series about a value that's not centered at 0, you have to use the long method of the Taylor polynomial formula. However, in certain situations, such as this example here, you can still use the shortcuts to help you with finding that particular Taylor series. The reason why we can do this is that when we go to plug in this x minus 2 into our Maclaurin series for e to the x, this is going to cause a shift in that particular Maclaurin series from a center value at x equals to 0 to a center value at x equals to 2. So let's see how this actually works. We know that the Maclaurin series for e is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on. And that goes on forever. And the general term of this particular series would be x to the n all over n factorial. Now, as I said, we're going to be able to use this Maclaurin series to help come up with the Taylor series for our given function centered at x equals to 2. And just like we've done to find other Maclaurin series or other particular Taylor series, all we have to do is take the expression x minus 2 and we're going to plug it into this Maclaurin series for e to the x, and wherever we see an x, we're going to, into that x value, we're going to plug in the expression x minus 2. So e to the x minus 2 should then equal 1 plus x minus 2 plus x minus 2, that squared all over 2 factorial plus x minus 2 whole thing cubed over 3 factorial. And that goes on forever and ever and ever. Alright, and now we have our first 4 terms to our Taylor series for our function, and you'll notice that because we're subtracting 2 from each of the x values, this Taylor series is indeed centered at x equals to 2. The only thing left to do for part A is to get the general term of our particular series, and that will be, we can get that just by plugging in x minus 2 into the general term of our Maclaurin series for e to the x. And thus we have our solution to part A of question number 6.